Hi everyone, it's Coach Fred here, and today I'm going to be solving a quadratic inequality or a polynomial inequality, and I'm going to be putting my answer in interval notation. So this could be for an Algebra 2 honors class, maybe an Algebra 2 trig class, pre-calculus class. So again, we're talking about polynomial inequalities. So it says solve each inequality and write your answer in interval notation. So I first want to make sure you understand those directions and what you're being asked to do. So this is a function, okay? And if I wrote that function like this, negative x squared times x minus 1, x plus 3, it represents a graph. So in this case, though, it represents an inequality. It's asking, where is this function? Where is y greater than or equal to 0? All right, so I took the liberty of graphing this on Desmos so you could see. So this is a graph of the function. And the graph is actually greater than or equal to 0 everywhere above the x-axis. And it's equal to right at those points right there. Now those points should kind of stand out to you. Those points are called the zeros of the function. All right, so that's actually how we solve an inequality. We find our zeros, which I'm going to refer to as our critical points. So I find my critical points. So in this case, we have x equals 0, x equals 1, and x equals negative 3. So then I have to see, now I graphed it, but normally I wouldn't. I have to see what's happening to my graph at those critical points and around it. All right, so since we know, actually let me change that to negative 3. So since we know at these critical points, it is equal to 0, I'm going to actually put a dot in there because I know it actually makes the inequality true if I plug them in. All right, so now I got to see what's happening here, 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 and here. All right, so how am I going to do that? Well, I'm going to just throw in some test points. I'm going to use the test points to the left and in between all those zeros. So I'll start with negative 4. Now here's the cool thing. You don't really actually have to get the value. You just have to see if, when I plug the value in, if this side is greater than 0, meaning it's positive. If it's not, then it won't be true wherever that number you plugged in is coming from. All right, so here's what I mean. Negative 4. If I plug in negative 4, I'm going to square it. I'm going to get a positive. So I'm going to have negative 16 times negative 5 times negative 1. So I have a negative times a negative, which is a positive. A positive times a negative is a negative. So my answer works out to be a negative value. We're looking for greater than 0, so it is not true. So I'm going to put a minus sign there, meaning it's negative. It doesn't work. All right, and then I'm going to try between negative 3 and 0, I'm going to try negative 1. So that's going to give me negative 1 times negative 2 times 2. All right, I can see I have a negative times a negative, which is a positive. Positive times positive gives me a positive. So it is true there. So I'm going to put a positive. All right, between 0 and 1, I'm going to try a half. Yeah, don't be scared with the number because remember, I don't have to actually do the calculations. So I'm going to have negative, in this case, 1/4 times negative a half times a positive 3.5. So negative times negative, again, gives me a positive. And so the last one would be 2. So negative 2, so that would give me negative 4 times 1 times 5. So I have negative 20 there, which it means it's negative. Okay. And so again, we want greater than 0, so we're looking for everywhere it's positive, which is from here all the way to here. So, and it equal to, so those are included. So in interval notation, it would be negative 3, comma 1 with brackets around it. Okay, so that's how you solve a polynomial inequality. Hopefully that was a helpful video. Have a great day.